Hello everybody, I'm Anupama Venugopal and I have 10 plus years of experience in the automotive software industry. So last I presented a video about the 24/7 debugging workflow and my plans to enhance it with further features. But before taking the next steps forward, I decided to take a step back, zoom out a little bit and revisit the design with a cybersecurity lens to make it more secure. Now you might ask why. It's because here we deal with a lot of customer specific data, which is quite confidential. So I might as well follow a secure by design approach to strengthen its security posture so that before making the workflow smarter with added RAG intelligence, I make it safer. So without much further ado, let me show you how I did this.
But first, the most important question: why cybersecurity? Cybersecurity matters not just for cybersecurity specialists, but also engineers working on connected systems. Gone are the days when embedded systems were closed loop systems, so essentially, what happened in the car stayed in the car. But today, they are more connected and communicate through Ethernet, diagnostics, backend servers, etc., which means that every new connection could be a possible attack surface. And automation workflows which support them could be an attack surface. After sharing the first version of the debugging workflow, I received some very thoughtful questions from all of you, and thank you for that. Some questions were about sensitive information, cloud usage, alternatives to cloud, AI output safety, and production readiness. And these are the questions which I want to address in this video. Other questions are also equally important, but they belong to the next stage because they were dealing more with private AI models, RAG, and EU AI Act alignment. So before making the workflow more intelligent, I want to make the foundation more secure. And for this, I structured the security hardening into 3 pillars. Pillar 1 is cloud security, where I secure the Enactin workflow, credentials, and webhooks. Pillar 2 is local processing security, where I focus on the local developers workspace, Python backend, and secure coding practices. And pillar 3 is AI data security, where I control what reaches the AI agent, validate the AI outputs, and keep human review in the loop. So the first pillar is cloud security. Conceptually, this is all about locking down the front door. We achieve this by implementing a zero trust, metadata only cloud orchestration layer. And what does that mean? It means the cloud orchestrator never actually sees downloads or interacts with the raw error logs. It only ever handles the metadata. This means we tightly control all cloud connected components. This is how the workflow looks after cloud security hardening. I divided the hardening into 7 phases, with each solving a specific security purpose. Let me walk you through them. Phase A is access and credential security, which means no hard-coded secrets and access is kept controlled using the principle of least privilege. Phase B validates input and allow listing at the workflow entry point so that untrusted inputs are quarantined before they enter the processing chain. In phase C, I protect the communication between Enactin and the Python backend using a shared secret which ensures that unauthenticated web requests are rejected before they reach the backend. Phase D deals with applying data minimization so that only the required fields are passed downstream instead of carrying raw logs through every node. Phase E follows a fail-safe approach. If a security check fails, the unsafe path is stopped or redirected before it reaches the down. Phase F makes normal workflow runs traceable by capturing key execution and security status in Google Sheets, and Phase G handles security failures by logging the incident, triggering alerts, and stopping unsafe output. So, Enactin Cloud provides platform-side controls such as SOC 2 and SOC 3 reports, U data center hosting, Azure-based infrastructure, and encryption at rest. But cloud security is still a shared responsibility, which means that the provider secures the platforms, but I still have to secure the workflow. So be the credentials, webhooks, input validation, data minimization, safe failure, and audit logging. And for the companies with stricter data control requirements, the same workflow does not have to stay only on Enactin Cloud. It could also be deployed using self-hosted Enactin, a private cloud or customer VPC, a hybrid setup, or edge AI boxes where sensitive processing stays closer to the engineering environment. So, Pillar 1 is not only about using cloud automation, it is about using it with controlled exposure and clear security ownership. Pillar 2 shifts our focus to local processing security. So, if Pillar 1 is the front door, Pillar 2 is securing the workshop itself. This ensures that when sensitive data is passed, it stays sandboxed within the local environment and never leaks. I will keep Pillar 2 brief here to avoid making the video too lengthy. In short, the goal is to secure the developer machine, isolate the scripts, and apply secure software development lifecycle coding practices to the local processing environment. And finally, we reach Pillar 3, AI data security, which is arguably the most critical trust boundary in the entire workflow. Pre-AI checks dictate exactly what data is allowed to reach the AI model. Similarly, after the AI model execution, post-LLM checks control the data cascaded further along. The pre-LLM guardrailing is done by a combination of code note and inherent guardrail nodes from n-arc10. Then coming to the AI agent, I have added retry handling of 3 attempts, each spaced 5 seconds apart. Now after the AI agent generates the RCA output, goes through a similar post-LLM guardrailing to check for unsafe wordings, URLs, overconfident root cause claims, etc. And if any of these checks fail, the workflow is redirected to an incident response stop path where the details are updated to a Google Sheet. Developer is sent a security incident alert before the workflow is stopped. So AI data security is not only about protecting data before it reaches the model, but is also about controlling what the AI is allowed to see, what it is allowed to generate, and where human judgment must remain in the loop. So yes, cloud platforms and LLMs may be secure, but my strategy is simple. Don't give the system more than it needs. So basically, don't invite attackers to a buffet. Give the workflow only the minimum data and access it needs for the job. And this is how we slowly move from cool automation demo to production grade engineering tools. Thank you for watching.